What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A+ 1201 certification exam. So let's get into it. When you first step into the world of IT, networking hardware, this can feel like a confusing alphabet soup. You got routers, switches, NICs, PoE injectors, and a whole bunch of other stuff. And exactly what do all of these devices do? And more importantly, how do they work together? Well, if you're studying for the CompTIA A+ 1201 exam, or you're just trying to figure out how your home or office network operates, then this video is your cheat sheet. I'm going to break down each of these common networking devices that are listed in the objectives and explain them in a way that makes sense to you. So with that being said, let's go. All right, so let's first talk about the router. So imagine a router as a GPS-equipped traffic cop that's sitting at a major intersection. Its job, well, it's to make sure that data, like your emails, your YouTube videos, and all this other stuff you look at, gets from your device to the right place on the internet. Now, a router, it connects different networks, and in a home setup, it connects your local area network or your LAN to the wide world of the internet, also known as the wide area network. And in the process, it assigns IP addresses using something called DHCP, and it provides NAT or network address translation to hide your internal IPs from the internet. And it also handles basic firewall duties. So here are some of the key router functions that you need to know about. So it routes traffic between networks. It assigns local IP addresses via DHCP. It provides NAT or network address translation for security and IP conservation, and it often includes wireless access point functionality in home networks. Now, as a side note, most home routers, like the one right here on your screen, these are actually 3-in-1 devices where they have a router, a switch, and an access point all built into one device. All right, next let's talk about the switch. Now, a switch, this lives on the local network. Now, think of it as the super organized event planner who knows exactly where everyone is sitting and sends messages directly to the right person. Now, when a switch receives data, it doesn't shout it out to everyone. Instead, it looks at the destination MAC address and sends it directly to the right port. And this is much more efficient than the old school method, which was used by hubs. And pretty much hubs are obsolete these days, so don't even worry about them. But when it comes to switches, you got two main types. You got the managed switch and the unmanaged switch. So when it comes to an unmanaged switch, these are basically plug and play devices. There is no configuration required, and these are perfect for home users or small networks where you do not need advanced control. And then you have what is called a managed switch, and these are configurable where you can go in there and set VLANs, monitor traffic, prioritize data using QoS or quality of service, and a whole bunch of other stuff. And these are ideal for enterprise environments where control and visibility matters. Now, the key takeaways for a switch are as follows. They operate on layer 2 of the OSI model, which is also known as the data link layer. They direct traffic based on MAC addresses, and managed switches, they offer greater control and monitoring than unmanaged switches. All right, next we have the access point. So access points, these are how your wireless devices connect to the network. While routers, they often include a built-in access point for home users. In business environments, you'll find standalone access points that are typically mounted on ceilings or walls. So you can think of an access point as a doorway to the network where it provides Wi-Fi access to wireless devices and passes that traffic to a wired switch or router. And some quick notes about an access point. So basically, they connect wireless devices to a wired network. They typically support multiple devices at once, and they operate using wireless standards like 802.11ac or 802.11ax. Now, as a tip, you do not want to confuse a wireless router with a wireless access point. A wireless router, this does routing and wireless access, whereas an access point only does the wireless access part. All right, next we have what is called a patch panel. So if you've ever seen a server room with dozens or hundreds of Ethernet cables all neatly plugged into a board with numbered ports, well, that is a patch panel. And patch panels, they do not actively move data. They are passive, like a really tidy extension cord. Basically, they serve as a central hub where you can organize and reroute network connections with short patch cables. So why would you use a patch panel? Well, they're easy to label and manage connections. They keep cables organized in larger environments, and they connect switches via shorter patch cables. So think of it like a phone switchboard from the old days, except now it's for Ethernet. All right, next we have what is called a firewall. And a firewall, this is your network's first line of defense. It monitors network traffic in and out of the network and decides whether to allow or block it based on a set of security rules. And there are two main types. First type is the hardware firewall. And this is a standalone device, or sometimes it's built into routers that protects an entire network. And then you have what's called a software firewall, and this is installed on individual devices to protect them specifically. And the capabilities of a firewall are as follows. Well, it blocks unauthorized access, it permits specific traffic like web browsing or email, and it can detect and prevent certain types of attacks. Now, as a tip, in corporate networks, you'll often find what are called next generation firewalls with deep packet inspection and intrusion prevention capabilities. All right, next we're going to talk about PoE, or power over Ethernet. So normally network devices like IP cameras or access points, they need both a data cable, or your Ethernet cable, and a power adapter. But with PoE, you can send power and data through a single Ethernet cable. And this is a game changer for placing devices in hard to reach places. And there are two main types of PoE devices. You got what is called a PoE injector. And this is a standalone device that injects power into a regular Ethernet cable. And this is great for retrofitting PoE into an existing network. And then you have what is called a PoE switch. And these are network switches that have PoE built into them, and they can power multiple PoE devices directly. Now, here are some PoE standards that you should know. So the first one is PoE, and its standard operates on IEEE 802.3AF, and it has a power output of up to 15.4 watts per port. You have what's called PoE Plus, and it operates on IEEE 802.3AT, and has a power output of up to 25.5 watts per port. And then you have PoE Plus Plus, and it operates on IEEE 802.3BT, and it has a power output of up to 60 watts or 100 watts per port. And the key benefits of PoE are as follows. So it provides cleaner cable management, and it's great for IP cameras, VoIP phones, and wireless access points. So when it comes to PoE, the great benefit of it all is that it offers simple installations and fewer outlets are needed because you have power running over the main cable in addition to data running on that same cable as well. All right, so let's talk about the cable modem. So if you have cable internet at home, then you are using a cable modem. And this device connects to the coaxial cable from your ISP or your internet service provider and converts the signal into Ethernet so your router can use it. And cable modems, they use a standard called DOCSIS, or DOCSIS, which stands for Data Over Cable Service Interface Specification. And this supports high-speed internet over the same lines as cable TV. Now, when it comes to a cable modem, just remember that cable modems, they convert coaxial signals to digital Ethernet. They usually connect to the router's WAN or wide area network port, and they are needed for cable internet, not DSL or fiber connections. And speaking of DSL, which stands for Digital Subscriber Line, this is another way to get internet into your home, but instead of coaxial cables, it uses your old telephone lines. And DSL modems, they connect to the phone jack and they use unused frequencies to transmit data. Now, unlike dial-up, DSL, this lets you use the internet and phone at the same time. And there are a few DSL types out there, including what is called ADSL, or asymmetric DSL, and VDSL, which stands for very high bitrate DSL, with each of them having different speed capabilities. Now, as a quick DSL fact, DSL uses what is called the RJ11 connector, which is basically your old landline phones. It offers a lower speed and range compared to that of cable and fiber, and this is mainly used in rural or older areas where people still have landline telephone connections. Now, when it comes to cable versus DSL, cable will usually win in speed and bandwidth, but DSL might be your only option in some areas if you live out in the sticks or something like that. All right, next we have what is called an ONT, or an optical network terminal. So if you got fiber internet, then the ONT, this is what connects your home to the Lightspeed fiber network. Basically, it takes the optical signal from the fiber line and converts it into electrical signals that your router can use. And ONTs, they are usually installed by your ISP, and they may be mounted inside or outside of your home. And when it comes to ONT, here are the basics. So they are required for fiber internet connections. They convert fiber optics into usable Ethernet signals, and they often include battery backups, especially for phone service. Now, without an ONT, your router cannot talk to a fiber network. All right, next we have what is called the network interface card, or the NIC. And the NIC, this is what lets your device communicate on the network. It could be wired through an Ethernet port or wireless through a Wi-Fi adapter, and it's built into most computers and laptops these days. So think of the NIC as your computer's passport to the network world. So exactly what do you need to know? Well, NICs, they live inside desktops, laptops, servers, and other devices. They provide the physical connection to the network, and they use a unique identifier, which is called a MAC address. And speaking of MAC addresses, or a media access control address, well, this is a unique 12-character identifier that is assigned to every NIC. And it looks something similar to this on your screen, where you got 6 groups of hexadecimal values to identify specific devices. Now, when it comes to the MAC address, this address is quote unquote burned in by the manufacturer and is used to direct traffic within a local network. Now, while IP addresses can change, MAC addresses, they stay the same unless they are spoofed. Now, why does this matter? Well, MACs, they are used by switches to forward data to the correct device. They help with device identification on the network, and they can be filtered in firewalls and routers for extra security. So remember this, your IP address, this is your address on the internet. Your MAC address, this is your name inside of the house. All right, so let's go ahead and wrap all this up. So let's zoom out for a second and see how these devices play together in a real world example, like a home or small office. So in a home or small office, you're going to have a cable modem or DSL modem that connects you to your ISP or your internet service provider. The router is going to assign IP addresses and connect local devices to the internet. The switch, which is built into the router or could be a standalone device, this links wired devices like desktops and printers. The access point gives wireless devices a way to connect. The patch panel organizes all of the cabling in a server closet. A PoE switch or injector, this powers IP cameras and access points. A firewall, this keeps the threats out and data secure. And NICs and MAC addresses, they keep everything identifiable and reachable. Now, understanding networking hardware, this isn't just about passing the CompTIA 1201 exam, although that is a big part of it. It's about building confidence in the real world, because when you know what these devices are and how they work and how they fit together, then you could become the go-to tech person that people rely upon. And at the end of the day, that is the goal, correct? So the next time you see some blinking lights on the switch or someone says, why isn't the Wi-Fi working? Then you'll at least know where to start, because you're not just learning definitions, you're building a toolkit that'll serve for years in your IT career. All right, so with all that being said, let's do some check on learning. So the first question is, which of the following networking devices is responsible for connecting different networks and assigning IP addresses to devices on a local network? Is it a switch, an access point, a router, or a patch panel? And the correct answer is this is a router. So a router, this connects multiple networks, most commonly your local area network or your LAN, to the internet or the wide area network. It also assigns IP addresses via DHCP and provides network address translation or NAT and basic firewall services. And switches and access points, they work within the LAN, while a patch panel is passive and used for cable organization. Next question. What is one key difference between a managed switch and an unmanaged switch? Is it that managed switches operate wirelessly while unmanaged switches do not? Is it managed switches can be configured for network control while unmanaged switches cannot? Is it managed switches assign IP addresses while unmanaged switches do not? Or is it unmanaged switches can convert coaxial signals to Ethernet while managed switches cannot? And the correct answer is managed switches can be configured for network control while unmanaged switches cannot. So managed switches, they offer advanced configuration options such as VLANs, traffic monitoring, and quality of service, while unmanaged switches are plug and play with no configurable settings. However, both types, they do transmit data within the LAN, but only managed switches provide administrative control. And our final question is, which of the following is a correct statement about power over Ethernet? Is it PoE requires a separate power cable and cannot send power over Ethernet? Is it PoE injectors are built into all unmanaged switches? Is it PoE can only be used with fiber optic cables? Or is it PoE allows both power and data to be sent over a single Ethernet cable? And the correct answer is PoE allows both power and data to be sent over a single Ethernet cable. So PoE technology enables power and data to travel through the same Ethernet cable, reducing the need for separate power adapters. And this is especially useful for devices like IP cameras and wireless access points. And when it comes to PoE injectors and PoE switches, they also provide this capability, and it is not limited to fiber optic connections.